Guys, I want to talk to you about probably the most important trig identity, because we use it pretty much anytime we're doing anything with trig, particularly identity problems. So you can see it right here written on my page, and I want to just kind of talk a little bit about it first by giving it a little bit of context here. So obviously we know that, there's this other way of doing angles at this point, and so we can use the unit circle. Well, when we use the unit circle, it starts to make a little bit more sense as to exactly like why this identity works and how it's kind of so important. So this is just my unit circle, just dividing into my cardinal angles. And we all know that like it's written in the form of cos x sine x to get any point along this unit circle. We also know that it has a radius of 1. Okay, so if I take any point at all on the unit circle like this, it will start to make sense really quickly that basically, if we take this radius here, 1, and we square it, it's going to be 1 squared. If I take any cosine, which down here would be my cosine of x, and over here would be my sine, and I square those as well, well then, through Pythagoras, we already know that those are going to be equal when we add those two squares. Now, these are not perfect squares, but you get the idea. So, of course, our sine squared plus cos squared has to be equal to 1, okay? All right, now, the other thing that you want to keep in mind when you're looking at this is that we can rearrange this a little bit algebraically and use some tricks. So we could simply subtract the 1 to the other side. So we could say like 1 minus sine squared x is equal to cos squared x. And likewise, we could also say that 1 minus cos squared x is equal to sine squared x. Okay? So that's just a little bit of like simplicity, I guess, and ways that you might see this thing also written or ways that it could be helpful. So let's actually use it here on this particular question. Now, one of the first things you should do, and this is what I always tell my students, is break things up into sine and cosine. It's a little bit easier. Okay? So back when you first started learning algebra, you often drew like a line like this and you kind of mirrored things. We're not going to mirror them. What we're going to do is keep things on our separate sides, and sometimes it's easier to simplify both sides. So over here, what I'm going to do is I'm going to take this tangent, and I know that tangent is really sine x over cos x. And then I'm going to multiply that by sine of x, and I'm going to add a cosine of x. Now, if I do that, I'm going to get a sine squared there. Okay, because I'm multiplying those over cosine. And if I want to add this, I would need to make this a fancy form of 1 or have a common denominator. So I'm going to multiply this by cos squared x over cos. Now, how did I do that? I simply took this one here and multiplied it by cosine over cosine. Okay? Now, as soon as I do that and I've got a common denominator, then I can put those two things together and write them as a single term. So that'll be sine squared x plus cos squared x. And this one's pretty easy. You can probably already see what's going to happen here. Okay, all over cos x. That sine squared plus cosine squared is going to simply turn into a 1. And so we literally just get 1 over cosine of x. And on our other side over here, we originally had secant of x. And of course, we know that secant is 1 over cosine x, or hopefully you know that. And so we can see that these two things here are indeed equal. Okay? Now, things can obviously get a lot more complicated. And then the next example that we do, they will be a little bit more complicated, but it's ultimately going to break down to just using that identity of sine squared plus cos squared x equals 1. And we just have to use it in different, or let's call them fancy ways. All right, guys, that's going to do it for this one. If you found this helpful, don't forget to like and subscribe. Tell your friends about us. We also offer tutoring services, so feel free to reach out to us. Look for Momentum for Life, and let's keep this momentum going.